Say that I managed to wrap a ribbon around the surface of the earth, and I'm doing it I'm wrapping it very tightly along the equator. So say that this is the equator. See, this line represents kind of the equator of the earth. It's tilted a little bit along its axis. So say that I managed to do this. I managed to wrap a red ribbon around the earth, and I do it tightly so as the ribbon is touching the ground in all parts of the earth. All this is hypothetical, and I'm interested in another scenario. That's why I have made a copy of the earth. I'm interested in another scenario where I raise the ribbon through a distance of 1 feet, and I do it equally throughout. What I mean by that is I raise the ribbon from the ground by a distance of 1 feet. Now it's not wrapped tightly anymore. I raise it 1 feet above the ground, and now this is kind of what I'll be having this scenario, and this distance that I have raised the ribbon along is 1 feet. So all these distances I'm marking are 1 feet above the ground. All these would be 1 feet, and what I am interested in is how much more ribbon would be needed in this process to go from the first scenario to the next scenario. I need how much more ribbon would be needed. So I hope you pause the video and have a go at it. And one hint for you would be that the radius of the earth need not be known to you. You do not need the radius of the earth to solve this problem. So I hope you have had a go at it and you are back for the answer. Well, let us think about this for a while. Let us see how much ribbon do we need to wrap the earth around tightly. That is in my first case. This is my first case. So let me see how much ribbon do I need. Well, let me assume that the radius of the earth along the equator, because what we have studied is it differs throughout, right? So just radius along the equator is r feet. I'm assuming in feet because this is what I have taken. I'm raising it through a unit feet. So let me assume that this radius is r feet. So the amount of ribbon required would be the circumference of that circle along the equator. So let me say that the amount required for this one would be 2 pi r feet, the radius of that circle. And now how much ribbon would be required for the second scenario? Well, I'm raising it 1 feet above r everywhere, and I'm doing this uniformly. So if this were r, or this were r, this were r, all these distances are r, and I'm adding 1 feet to it throughout. So my radius of the circle formed by the ribbon is increasing by 1 feet. So my new radius would be, so this case would be, I'm drawing a lot of arrows, but I hope it's not very confusing. So the new radius would be 2 pi times r plus 1, because that's my new radius now, r plus 1. So my new circumference would be 2 pi r plus 1, and this is how much ribbon I require for the second case. This is my second case. So how much more ribbon do I need? Well, I already have this amount of ribbon. Now I need this much. So let me subtract both and see what I'm getting. So let me switch to a neutral color now. 2 pi r plus 1 minus 2 pi r. This would give me how much more ribbon I'll be needing. And this simplifies to 2 pi r plus 2 pi. I'm just distributing 2 pi throughout. And this is 2 pi r still. And now you see my radiuses cancel out. But this is the reason why I told you don't actually need the radius to find this answer. And we are getting 2 pi, let me say 2 pi feet more ribbon, right? That will be the units. And how much would it be? Well, 2 pi is almost 3.14. Well, pi is 3.14. This is 3.14. And you can approximate 2 pi to be 6.28 feet more. So not that much, right? Considering the size of the earth, it is irrespective of so it's not dependent on the radius. So 2 pi 6.28 feet more ribbon is what I'll be needing, and this is actually kind of the outcome of the ratio of the circumference and the radius being a constant. So this puzzle deals with that fact. It might be less intuitive, but the ratio of the circumference to the radius is, if I'm right, this is 2 pi. Or another way of saying that would be the ratio of circumference to the radius would be, to the diameter would be pi. And this puzzle makes use of that fact.